Hey guys, it's Steve with Aptera Owners Club. I've had a few days to digest this Elaphe webinar about efficiency, and I wanted to make a video to give you just my takeaways from it. Your takeaways are probably a little different, and maybe I'm not understanding this correctly, but this is the way I understand it. So I downloaded their slide deck from their website, and let's go through it. So this is a little bit of their history. They started back in 2006. And they have two models that are going to be launched Q4 of 2022. This is probably Lordstown and Aptera, and then they have another model, and I don't know who that is. That's Q2 of 2023. They're talking about all the different EVs that are being introduced. There's a lot of them, and talking about how the EV is now segmenting to different types of cars. And here's Aptera, substantial daily range without charging. And they're talking about how there are these ultra efficient vehicles now. And the three ultra efficient vehicles, they're talking about the Lightspeed, the Aptera, and the Mercedes EQXX. And so basically, all of these are like as light as possible, low drag, low rolling resistance tires, and then optimization of internal losses. And this one is useful autonomy without charging. This is solar, and so is this. All right, so then they talk about how you basically have these charging losses, and these are auxiliary consumers, is like AC, heat, powertrain losses, rolling resistance, air drag, that kind of stuff. And then you can get some back by regenerative braking and stuff. And what you want to do is, if you want to increase efficiency, you want to focus on air drag. So you reduce frontal area, reduce coefficient of drag. That's what Aptera is doing. Then focus on rolling resistance. You get tires that have better rolling resistance. Change their size. Usually thinner tires are more have better rolling resistance. And then these highlighted reduced vehicle mass. So the lighter vehicle is definitely going to be more efficient. Something else to consider if you're thinking about getting the giant battery pack. Maximizing regenerative ability, improve thermal management, and then improvement of losses for each internal component. And then, of course, one of their big pluses for having an in-wheel motor is you have more space to put the battery. So like see in the e-axle, this area on a Tesla and other vehicles is filled with the powertrain components. And then the central part is the battery. And then here you can make the battery bigger because you don't need this central area. This area between the wheels can be used as well. All right, so there was some technical stuff here. I think we need to get to this part. So I don't know if this formula makes sense, but it makes sense intuitively, and I just take their word that they're car engineers and they know more about this than I do. But basically, the really important take-home message here is this is the amount of power that you use to to overcome the rolling resistance, the vehicle mass, and the aerodynamic drag. So this is the amount of power that you use to move the vehicle forward. And then this is the powertrain losses. Okay, so if you look at this, if this is a smaller number and this stays the same, powertrain losses stay the same, the powertrain losses become a bigger factor in this formula. So like, let's say that this is 10 and the number of this is 10, then this 10 has a larger effect on this because then this becomes 1 over 2. And so if you change this a little bit, like make this powertrain losses 5, it becomes 1 over 15 instead of, 1 over 1.5 instead of 1 over 2. Whereas if this road losses is really high, let's say like it's 1,000, then this being 10 makes it 1,000 over 1,010, which is not a big difference. So basically the take-home point here is that the more efficient a car is, the more important the powertrain losses is as a proportion. And that just intuitively makes sense. If you have like a giant vehicle like a Hummer EV that's really inefficient to start with, it's just using a ton of power to move the car, then the little bit of powertrain losses don't really affect that. because it's just overwhelmed by the total inefficiency of the car. But if you have a very efficient car like an Aptera that uses very little power to move the vehicle, then even slight changes in the power efficiency affect the overall, has a greater impact on the overall efficiency of the car. So that totally makes sense intuitively. And then we're just going to skip to here. They're talking about the different powertrain losses. So the in-wheel, so you can see that many of these are shared between the e-axle and the in-wheel motor. So joule losses in the motor, in the electric motor, that's the same. Frequency losses, so frequency losses are an effect of RPM, joule losses are an effect of torque. And then here's some differences. So the inverter losses are the same, cable losses are the same, and vehicle bearing losses are the same. What's different is in-wheel motors have seal losses because they have seals, and there's a little bit of drag and friction on the seals of the in-wheel motor, and that doesn't exist in the e-axle. And then what the e-axle has that the in-wheel motor doesn't have to deal with is there's gear losses from the bearings and seals in the gearing, the drive shaft losses, and the joint losses from like the CV joints and stuff. So it's basically, if you want to compare the two, it's seal losses versus gear, drive shaft, and joint losses. So an axle has multiple points of power loss in the powertrain. And so they're going through here, they mapped out the efficiency based on RPMs and on axle torque. And you see here that the sweet spot for the in-wheel motor is here, and the sweet spot for the e-axle is here. So basically the e-axle, in terms of powertrain, so this is taking away vehicle rolling resistance, air resistance, that kind of stuff. But if you want the maximum efficiency of the powertrain, that is better at relatively high torque, so under acceleration or going up a hill, fairly steep hill probably, and at higher speeds, whereas the in-wheel motor is better at lower speeds and at lower torque, which is good for the driving that most people do. So I didn't really understand what this wheel RPM and torque meant, so I just kind of did some calculations. So I don't know, like, what does 1,000 RPM at the wheel mean in terms of like mile per hour speed? What you need to do is you need to figure out the circumference of this wheel and then figure out how many, do some math to figure out how fast that is. So we know the wheel size of the Aptera is 195/45 R16. Okay, 195/45. So the 195 gives you the width of the wheel in millimeters, and the 45 is the aspect ratio. So 195 times 0.45. Okay, so this is the sidewall height of the wheel. So this is in millimeters. To get it to inches, you divide it by 25.4. So that's how many inches the sidewall of the Aptera wheel is. So to get the diameter, you multiply that times 2 because there's 2 sidewalls and a rim in the middle. So times 2, that's about 7 inches. Then it's a 16-inch rim, so plus 16. Okay, so this is the diameter of the wheel. Then you divide this by 12 to get feet. So the diameter of the wheel is almost 2 feet. Then you multiply times pi, 3.14159, that should be close enough. That gets you the circumference of the wheel. The circumference of the wheel is about 6 feet. Then if you have 1,000 RPMs times 1,000 RPMs, so in 1 minute, it's going about 6,000 feet. So there's 5,280 feet in a mile, so let's divide that. So you're going about 1.13 miles per minute. You multiply that by 60 because it's 60 minutes an hour. So that's 68 miles per hour. All right, so now we know how to kind of look at this thing. All right, so we know that this is about 60 miles per hour, 68 miles per hour, which is kind of highway cruising speed in this area. And so 500 is about 30 miles per hour. And this is less. And then I wanted to know, like, how much torque do we usually generate during vehicle use. So I looked at this. I found this research publication that talks about the speed of a vehicle, so going from about 20 to 120 kilometers per hour. You see that the torque here during acceleration goes up to about 500 newton meters, and then during cruising speed, it's hanging around 100 newton meters. And so this is engine torque, and usually torque at the low end, it's like a 2-to-1 or 3-to-1 ratio. And so you would expect acceleration torque to be about 800 by 1,000 newton meters. So that's roughly kind of in this area of acceleration, under hard acceleration. These dots show where the axle torque and wheel speed are during their during a European cycle test. So obviously they're not accelerating too hard in these tests. If you do max acceleration, it's probably hanging out in this area. But here's the very interesting thing. You see that most of the cycle ends up in the sweet spot. So red is where you want to be. That's the sweet spot. You almost never get into the perfect efficiency of e-axle. E-axle motors, according to this graph, are most efficient at high speed under high load. That's their most efficient area. Now you're going to burn through a ton of power at high speed and high efficiency because you're fighting, the rolling resistance, aerodynamic drag, and vehicle weight. But in terms of powertrain alone, that's the most efficient. Here, the powertrain is most efficient in the area time that most people are driving, which is cruising at highway speed at like 70 miles an hour. So that's very efficient there. And it's efficient kind of cruising at like 40 to 50 miles per hour too. It's least efficient. So where it's less efficient than an e-axle is right off the line at a standstill. So like until you hit about 10, 15 miles per hour, the e-axle is more efficient. But then after that, you're better off with the in-wheel motor. So you see overall, based on the test cycle, the in-wheel motor is much more efficient. This means that the Aptera most likely is going to be a great highway cruising vehicle. It's very light. The aerodynamics is very good, and the powertrain is most efficient when cruising at 50 to 70 miles per hour. And then the last thing that was important to find out from this thing is that these losses are sensitive to cold. So the e-axles do worse in cold weather. The in-wheel motors are better in cold weather. I'm guessing, and I don't know, but I'm guessing it's because the gear, the grease and the lubrication for all these mechanical parts just don't function as well in the cold. And so you see that the difference between in-wheel motors and e-axles is much greater in cold weather. All right, so that's kind of the take-home points I got from the presentation. If you guys had other take-home points from the presentation, please comment below. And if you want to watch the whole presentation, I'll link that in the description. So thanks for watching, and everyone have a great day.